Alright, so let's get into it now. So we have differentiation from first principle. So, and how does it work? So the question says differentiate the following from first principle. So that means that we take the actual definition of differentiation and we use it to solve. So this could imply that many times when we want to differentiate, we actually don't use first principle, and that is true. But in this case, it's quite very important that you learn how to differentiate from scratch, how the concept was derived. So we have about 8 questions here: A, B, C, D, E, F. Okay, G. For apparently I forgot my alphabet. So let's do it now. So this is how it works. So just to remind us one more time, the definition of the differentiation, we say dy dx is equals to lim as delta x tends to 0 of f of x plus delta x minus f of x over delta x. But you see, the reality is that we won't really be using this. We will really not be using this. There's something we are going to do, and let's get to it from the first explanation. So we have the first one. We say y is equals to 2x. So that's how it goes. Y is equals to 2x. So what do we do now? So what we're going to do is that we introduce a small change to your x. Your small change is going to be your delta x. But we know when we introduce a small change to delta x, it is going to cause a small change in our y as well. So what we are going to have is that, okay, so because y is 2x and we say 2, your open brackets, because your x is there, so we have x plus delta x. So essentially we are adding a small change to your x, so your y is going to respond and say y plus delta y as well. So we have y plus delta y is equals to 2 open bracket x plus delta x, because the 2 is multiplying the x, so it takes up the entire thing that is there. So we go on to say, okay, what if we have y plus delta y? We're going to expand and say, okay, we say 2x plus 2 delta x. So that's what we have from there. So what do we do next now? We need to, in this concept of differentiation, we are really interested in getting the change, right? The change. So we are not really interested in y itself and what x itself is. So let us subtract both sides from by y so that we get the original thing we are doing. So we can subtract both sides by y by saying y plus delta y minus y is equals to 2x plus 2 delta x minus y. So if you do that on the left hand side, we have what? Delta y there equals to, now there's nothing to subtract y by, but if you go back to the original line, we say that y is your 2x, so we are going to make the substitution and say, okay, 2x plus 2 delta x minus 2x. Now 2x minus 2x is 0, so we are left with delta y is equals to 2 delta x. So now the next thing you need to do is that you can divide both sides by your delta x. So we are going to have that your delta y over your delta x is equals to 2, because you divided both sides by delta x. So the final step now is to take the limits, and that's what we say your dy dx is equals to limits of delta x as it tends to 0 of 2. So now there's no delta x in our work, in our function left. So all we just do and say is that your delta y, your dy dx is equals to 2, and that is the answer to that. So in this question, we've successfully differentiated your first function. So that means there's a relationship of 2 when we take the rate of change of your y equals 2x, right? So that's what the function is trying to tell us, our derivative. So let's take the next question now. Question B, it says y is equals to x squared. So we follow similar steps as we did the first time. So we introduce a small change in our x that will produce a small change in our y. So we are going to have y plus delta y is equals to, you open your bracket now and say x plus delta x all squared. So we go on to say we have what? Y plus delta y is equals to, now let's square this. We're going to have this to be x squared plus 2x delta x, then plus delta x all squared. So that's delta x all squared, right? So that's what you have after squaring this. Okay, so what do? We subtract y from both sides, and you know that's just basically going to leave us with delta y, and you know your y is just your original function again. So really you are saying this as x squared plus 2x delta x plus delta x all squared, and you subtract x squared from it. That's what we have there. So you know that your x squared minus x squared, and you're left with your delta y is equals to 2x delta x plus delta x all squared. So what do you do next? You divide through by delta x. So when you do so, you have your delta y over delta x is equals to now 2x delta x divided by delta x. You're left with 2x. Now your delta x all squared divided by delta x, you'll be left with delta x. So it turns out that your delta x over delta y is equals to 2x plus delta x. So of course, now to bring up the limits, you're going to say your dy dx, which is the final result, is lim of delta x as it tends to 0 of 2x plus delta x. So in this case, there's delta x present there, and what does this limit do? We will replace the distinct delta x with the 0 that is here. So we say your dy dx is equals to 2x plus 0, which ends up to become 2x. So in that case, your dy dx is equals to 2x. Let's go on to the third example. So we have y is equals to x cubed. So of course, I believe you should know the pattern by now. So we are going to say y plus delta y equals to x plus delta x all cubed. So we have y plus delta y. So now the effort is to try to expand this. So let's quickly make use of Pascal's triangle to expand it. So in Pascal's triangle, we have something like this. We have 1, we have 1, 2, 1. And we have 1, 3, 3, 1. So remember, we are expanding x plus delta x all cubed. So in the first case, we have our coefficient of 1, and then our x is raised to the power of 3, and our delta x is raised to the power of 0. Then we take the next guy, which is 3. So we take 3, and we take our x now raised to the power of 2, and our delta x is raised to the power of 1. Plus take the next guy, 3. So that is our x will be raised to the power of 1, and our delta x will be raised to the power of 2. Then finally, we take this 1, and we say our x is raised to the power of 0, and our delta x is raised to the power of 3. So we are going to have it to become what? 1 times s cubed. This is basically 1. So this is still as 1. So 1 times s cubed times 1 will leave us with x cubed plus, now we have, this is going to give us delta x. This is x squared, and this is 3. So we have 3 times x squared times delta x will give us 3x squared delta x. Now plus, now 3 times x times delta x all squared is going to be 3x. You can write this as delta x all squared, then plus 1 times, this is 1 times delta x all cubed. You can write it as delta x all cubed. So that's the expansion of the function that we need. So let's put it in our work. So we're going to have this to be, let's see if I got it right. We have it to be x cubed plus 3x squared delta x plus 3x. Now that's delta x all squared plus finally delta x cubed. So that's that. So what do we do now? We subtract the y from both sides. So that's subtracting y here and subtracting the original function here. So we'll be left with delta y is equals to be x cubed plus 3x squared delta x plus 3x from bracket delta x all squared plus delta x all cubed minus x cubed. So x cubed subtract x cubed, we are left with delta y equals 3x squared delta x plus 3x delta x all squared plus delta x all cubed. So what's the next thing we do? We divide through by delta x. So we have your delta y over delta x is equals to, when you do so here, we're left with 3x squared. Then when you do so here, you're going to be left with 3x delta x. Then when you do so here, you're going to be left with delta x all squared. We divided each of them by delta x. So now your dy dx is why you take the limits. So you take the limits of delta x as it tends towards 0 of the function, and that's going to be 3x squared plus 3x delta x plus delta x all squared. So that's going to be what? So this guy, we are left with 3x squared here. So plus this is 3x open bracket 0. This is 0 squared. So this is going to be 0 and this is 0. So that means we are finally left with what? 3x squared, and that is our dy dx, like that. Okay, so moving on to the next one. So we have the next one to be y equals to 1 over x. So we have question D to be y equals 1 over x. So what do we do here? We do the same thing as well. So we go on with y plus delta y is equals to 1 over x plus delta x. Basically, wherever state or form we meet our x is where we are going to add the increment. So what do we do on? We go on to say to subtract the original function from there. So y plus delta y minus y is equals to 1 over x plus delta x minus 1 over x. So on the left side we are left with delta y. So here we have two fractions which we need to subtract. The LCM is x open bracket x plus delta x. So this cancels this, we're left with x. X multiplied by 1 is x minus x cancels x, and we're left with x plus delta x, which we leave in a bracket x plus delta x. So if we go on, we have that delta y is equals to x minus, if we open this bracket, x minus times delta x is minus delta x over x open bracket x plus delta x. So we're left with delta y equals to x minus x is 0. We're left with here minus delta x over x open bracket x plus delta x. So what we need to do is to divide both sides by delta x. And if you remember from mathematics, when you divide both sides by something, it's also the same thing as multiplying that thing by 1 over this. So this is it. If you divide 9 by 3, it's the same thing as saying 9 times 1 over 3. So we are going to apply that neat approach here. So we are going to say delta y times 1 over delta x is equals to minus delta x over x open bracket x plus delta x times 1 over delta x. So easily you see from here that this cancelled this, and then we are left with delta y over delta x is equals to minus 1 over x open bracket x plus delta x. So the next thing you need to do is to put your limits, and that is when we have your dy dx is equals to lim of delta x as it tends towards 0 of minus 1 over x plus delta x. So that is what? Minus 1 over x plus 0. Now our answer is minus 1 over x. So that means that your dy dx for this case is minus 1 over, oh sorry, I forgot to do this. There's an x here, x open bracket this, so we have x open bracket this, so we have x multiplied by x, which is minus 1 over x squared. So that is minus 1 over x squared. So the mistake was I forgot to put this there. So we have x is there, so delta x is 0, so x times x is x squared. We have our answer to be minus 1 over x squared.